In this video, we're going to review the concepts that we learned in Chapter 10, and we're going to start with 10.1. And this review should help you with problems 1 through 15 on the chapter review. So in 10.1, we had a couple of formulas. The first was the sum of interior angles of a polygon. So n represents the number of sides of the polygon. So you would replace, for instance, if you were looking for a pentagon, you would replace n with 5. So the formula is 180 times n minus 2. If you're looking for a single interior angle of a regular polygon, and that's key, it has to be a regular polygon or else this formula does not apply. So I'm going to star it in yellow. Must be a regular polygon. The formula is 180 times n minus 2 divided by n. If you're looking for the sum of the exterior angles, if you want the entire sum of the exterior angles, no matter what polygon you're looking at, the sum is 360. But if you want a single exterior angle of a regular polygon, it would be 360 divided by n. And this is another one that must be a regular polygon. So remember that they do not apply to just any old polygon. They must be regular polygons, meaning all sides are equal and all interior angles are equal. So let's use these formulas on an example. I have a 12-gon, and for the following, I'm going to tell you that the 12-gon is regular, but for the ones marked with an arrow, it could be any old 12-gon. Okay, so let's find the sum of the interior angles of a 12-gon, which is a 12-sided figure. So that would be 180 times 12 minus 2, which is 180 times 10, which is 180 with 1 0 added, so it would be 1800 degrees. Okay, how about if we wanted to find one interior angle of a 12-gon? Well, we would take the 180, 12 minus 2, and then divide it by 12. So we know what 180 times 10 is. It's 1800. Now we need to divide 1800 and 12. Well, I know that 6 goes into both of them. 6 goes into 1800 300 times, and 6 goes into 12 twice. So my final answer is going to be 150 degrees. All right, how about if I wanted to find the sum of the exterior angles? Well, that's an easy one. That will always be 360 degrees. But if I wanted to find one exterior angle of a regular 12-gon, I would take 360 degrees and divide it by 12 to get 30 degrees. Each exterior angle would be 30 degrees. Okay, so let's go ahead and work a problem like this where we're solving for a missing variable. Well, the first thing we need to know is what do all of the angles on the inside add up to? If I know that, then I can solve for my variable. Well, this is a pentagon. A pentagon has 5 sides. And this one, since we're using the sum of the interior angle formula, we do not need a regular polygon because this is not a regular polygon. So for a 5-sided figure or a pentagon, okay, so what would that be? I have 180 times 5 minus 2, which is 3. So 180 times 3. 3 times 180 is 540 degrees. So if I add up all the angles inside this pentagon, this one, this one, this one, this one, and this one, they should add to 540 degrees. So let's go ahead and do that. 115 degrees plus 117 degrees plus 100 degrees plus 105 degrees. 1, 2, 3, 4 plus x degrees should be 540 degrees. So 115 and 117 would be 232. So this is 232 degrees. 100 plus 105 is 205 degrees. Plus x degrees is 540 degrees. So when I add these two, I get 437 degrees plus x degrees should be 540 degrees. So when I subtract 437, I get 63, and 40 is 103 degrees for my answer. And that would be how you would solve a problem like this, where you have interior angles and you have a variable to solve for. All right, let's go ahead and move on to 10.2. This is where we learned all of our formulas for finding areas of our different shapes. I'm not going to go over all of them, but you can see them in front of you. I'm not doing an example of a square and a rectangle because you guys should know that already. But I will do triangle, parallelogram, kite, rhombus, and trapezoid. All right, so here we go. So we have the area, or we have a triangle, and they're asking us to find the area of it. Remember, the height is always perpendicular, so this must be the height. Perpendicular to the base, you can see the perpendicular symbol right here. So I know 3 inches is the height. So let's go ahead and plug that into my formula. Area equals 1/2 height times base. So I have the area equals 1/2 times the height, which is 3, times the base, which is 5. So I end up with 15/2 inches squared. And that's the area for that triangle. So the area for a parallelogram equals height times base. Again, my height is perpendicular to my base, so this must be the height. So my area is going to be a height of 4 times a base of 7 inches. I get 28 inches squared. All right, so for my kite, I know it's a kite because I have 2 sides that are congruent, and the other 2 sides are congruent, and these sides are consecutive. Okay, so I need to find my diagonals because the area formula is 1/2 diagonal 1 times diagonal 2. But I don't have all of my diagonals here. Well, what do I know about a kite? I know that this piece here is equal to this piece here, so they must both be 2 inches. So one of my diagonals is going to be 4. I'll call that diagonal 1. 2 plus 2 is 4. My other diagonal, let's just add the numbers across. That is 10 inches, and this guy's 2 inches, so that's going to be 12. When I reduce, I get 24 inches squared. All right, let's do our trapezoid here. Okay, in this case, I need to find a missing side because my area formula is 1/2 times the height times, oops, and I didn't put that in, base 1 plus base 2. So I have a nice right angle here. So I know my height, all right? It is perpendicular to my base. I know one of my bases, but I don't know the other base, so I'm going to need to calculate it. So what I'll do is I'm going to drop down a perpendicular side here and turn this into a rectangle and a triangle, which means this side is 4 and this side is 6. But I'm missing this side. So I have a nice 30, 60, 90 triangle, which I'll draw right here. This is 60 degrees. This is a right angle, and I know this is 4. Oh, that's a crappy triangle. Let's go ahead and draw that again. That makes it easier to see, right? This is 4, so this is 30. I need this piece on the bottom here where I put my little question mark to go from the long leg to the short leg here, right? I need, when I label this, this is going to be 2x, this is going to be x, and this is going to be x radical 3. So I'm going to set 4 equal to x radical 3, and then I'm going to divide by radical 3 to solve for x. And I also have to rationalize, so 4 over radical 3 times radical 3 over radical 3 equals 4 radical 3 over 3. This is my missing piece right here. So my base is a combination of 6 and 4 radical 3 over 3. All right, so I'm going to go ahead and erase my work so that you can see what I'm doing here when I finish off my formula. I'm going to plug in 1/2. My height is 4. Base 1 is 6. Base 2 is a combination of this 6 and this, it's addition. 6 plus 4 radical 3 over 3. When I reduce the 2 and the 4, I get a 2. When I combine like terms, I get 12 plus 4 radical 3 over 3. And when I distribute that 2, I get 24 plus 8 radical 3 over 3. And that was, they didn't give me units, so it's just units squared. Okay, my last example for this is a rhombus. What are the properties of a rhombus? Well, for a rhombus, I know that the diagonals bisect each other and that they intersect in a right angle. So I know this and this are congruent, and I know this and this are congruent. Okay, I'm going to put little circles on this because I already have that mark on my picture. So the area formula for a rhombus is 1/2 diagonal 1 times diagonal 2. I need the full diagonal, not just part of it. So this piece here is 5, this piece is 5. If this piece here is 7, this piece is 7. So my total diagonal for diagonal 1, the one going up and down, is 5 plus 5 is 10. The one going left to right is 7 plus 7 is 14. So I'm going to reduce my 2 and 14 so that I can multiply by 10. That's always easiest. So I get 70 centimeters squared. So I believe that's it. This should help you with problems 1 through 15 on your homework.